You're listening to The Interactome, a podcast by a group of young researchers who want to connect you to the world of science by sharing their stories and perspectives. Just in case their bosses are listening, they want to remind you that the opinions expressed here are their own. They also want to remind you not to take anything they say as medical or professional advice, as they are not doctors. Not yet, anyway. Stay tuned about that. And, without further ado, welcome to the Interactome.
Hi everyone, and welcome back to the Interactome. For this episode, we're going to be doing another science stories. So we've all prepared little stories to talk through. Sam, stop making faces at me. You guys can't see it, but Sam is making faces at me in the Zoom, and it's making me nervous.
Prepared is a strong word for Joe.
Well, we all have a vague idea on what we're going to talk about, and mainly this is just going to be a fun conversation, talking about birds and snails and research. So if you're interested in those things, you've come to the right place.
Oh,
so
boy.
just a background, I'm Natalie. I am a co-host on the Interactome, and that's pretty much it, I guess.
I'm Sam, and I can already tell it's going to be one of those episodes. I am a researcher in the biotech and pharmaceutical industry. So I guess I arguably a researcher, but that's a long story for another day. And last but not least,
oh yeah, we have me, Joe. Yeah, also obviously a co-host, but I'm a MD PhD student over at the University of Pennsylvania, in the thick of med school right now, but taking a break to talk about some fun science things. So I'm looking forward to whatever stories we manage to put together here. Yeah.
Joe is tired tonight. I don't know if you can tell from his voice.
It's I'm having a time, but right now it's a good time. So let's
I'm having a time, and it's a good time.
yeah,
and I guess everyone gave background. So I'm a communications professional. So I work a 9-to-5 comms job. And I do this for fun because I love science communication. I love hanging out with my friends.
Woo! Yeah, it's funny. I think with Joe and a few of our other hosts who are in med school, I think I've been learning from a distance that med school has the reputation it has for a reason.
No, but actually.
So we very much appreciate Joe's being here. So I don't know who wants to go first. I mean, I'm very excited for my story, so...
then kick it off.
Spill it.
I think Natalie and Joe, you have both been subjected to my story before. In fact, I'm trying to pawn off part of it on Natalie if she'll take it.
Almost succeeded. Not really.
Oh no. So the I guess I'll start with the strange sentence, which is, I have too many snails. That's where this is coming from, and the process of ending up with too many snails has taught me a lot about biology. Long story short, a year or so ago came into possession of a fish tank, some fish and some snails. Actually, not the tank. I had to figure that one out myself. But the two snails, and snails don't live very long, so I got another snail at some point. And snails are a pretty diverse group of mollusks, come to find out. So the particular kind of snail I have is referred to as a mystery snail. It's in the apple snail family, but that's actually... they're not usually referred to by that name in a lot of contexts for some pretty important reasons, but...
Can I ask a question?
Yeah.
So, when you say it's a mystery snail, is that the actual species name?
Yes.
Or is it like we don't know what kind of snail? Okay.
Yes, it's called a mystery snail, and it's also related to the issue with having so many snails. So, not the issue, the reason I have so many snails. So, the thing you have to know about mystery snails, and this is not true of all snails, is that they reproduce sexually. There are male and female mystery snails. And so one would think that this means that you must have 2 snails in the tank to end up with more snails. And furthermore, that this only happens with a certain combination of 2 snails. And so when having in my possession only a single mystery snail, I was surprised by the sudden mystery of a lot more snails. And supposedly this is actually how they got their name, is that essentially you can end up with a bunch of mystery snails that you don't know where they came from. And
that's so funny.
So the origin of these particular snails comes from the fact that while there are male and female snails, and my current snail, who I've named Houdini, is apparently female, but if they mate once, they can lay the eggs resulting from that as much as 6 months later, I believe. It's like some insane amount of time. And they'll just hold on to that genetic material, then plop out some number of eggs, and then they also lay those eggs out of the water, and I have no idea where they were laid. So the fish tank has a cover on it because I didn't want the snail to be able to crawl out, because mystery snails, while they are aquatic snails, can live out of water for up to 3 days, and they will sometimes choose to do so. Houdini, when I put her in the tank, went up to the top of the tank and immediately went out of the water when we put her in. Hence the name Houdini, because she was trying to escape. And so I now have a bunch of these little snails, which the first one I named Houdini because I was being clever. 3D doesn't roll off the tongue so much, but I now have N-Dinis in my tank. N is some number greater than 8 or 9.
And you really have no idea how many are in there?
I have no idea. So the thing about them is when they hatch, they're teeny tiny. So I was reading papers about mystery snail reproduction, and you need a microscope to see the juveniles to begin with. And there's also plants in this tank, so at some point they stop being microscopic, and there's just like these little pea-sized snails crawling around this fish tank. And they grow up to be the size slightly larger than a golf ball. So you can understand why having some number in the vicinity of 10 golf balls in a relatively small fish tank would be a problem, let alone the fact that those golf balls are eating and pooping and existing as organisms into themselves. It can be kind of an issue. And this property of mystery snails, and I guess this is probably true of some other apple snails, though they didn't do too much digging to that, can lead to some problems too. So while me trying to figure out who to give these snails to and trying to see if I can convince Natalie to take a small fish tank and a snail is, a challenge for me, they can also be a challenge in places like India if someone has a pet snail and then it gets loose and then just starts laying eggs everywhere. Because you end up with these golf ball sized snails that can live out of water for up to 3 days, etc., multiplying rapidly through your otherwise pristine ecosystem. Well, maybe not pristine, but definitely would do better without a bunch of giant snails in it. This is not really an issue in the continental United States because temperatures below 50 degrees Fahrenheit will kill them. Houdini is in a heated fish tank and is blissfully unaware of the New England winters. But if any of these baby snails were to get out, they would suddenly become aware of the New England winters in a big way. And unlike some of my neighbors, would probably not be content wandering around in shorts and drinking a nice coffee. They would be dead.
I can just see that being like a meme, like a snail with like a Dunkin's iced coffee like Photoshop next to it and like jorts. Like that's just what comes into my mind.
For those of you who aren't from New England, particularly those of you who are in climates where a mystery snail might actually fare pretty well, this is in fact what happens in New England. If you ever come here in the winter and you're not used to those sorts of temperatures, bring a coat. But there are definitely people out there wandering around far less well dressed. That's kind of the beginning of kind of my adventures with mystery snails. But I think that like having a small organism that you're otherwise unfamiliar with in your house can be an enlightening experience. Snails, I think you think about them kind of in pop culture as being slow, sedentary beasts that kind of hang around and don't move very much. And while that's true of some snail species, probably, that is not true of mystery snails. I actually once saw a snail jump over a fish. And, it just managed...
Wait, what?
They can contort themselves in all kinds of interesting directions. And so I have these like 2-inch long fish in there, which they're a whole nother story. But the snail can just kind of warp around. It was like it's stuck to the glass on one side and the sand on the other. It just kind of shoop right over the fish. And so they'll book it. So like fish tank might be like 1.5 feet, 2 feet across, and like it can go from one end of the tank in like a minute or so. Like just they are speedy and voracious eaters. They have rows of like a tongue like covered in tiny little teeth, which sounds horrifying, but it's this.
Ew.
It just looks like a cute little.
Sorry, but what?
It's really. It looks just like a cute little mouth, like opening and closing against the glass, which is like eating algae off of it. So it's just like kind of like little Pac-Man mouth on the bottom of the snail. It's really. It sounds horrifying, and I'm going to tell another favorite story about snails in a second that will make them even more horrifying. But it looks almost like a beak. So, in fact, the beaks on squid are the same sort of structure, but in the squid family, because they're both mollusks. The radula, the toothy tongue, is the same thing that is a squid's beak. And so with a mystery snail, it almost looks like a little beak that's like scraping against the glass with, and it keeps the fish tank incredibly clean, which is good because I don't really feel like scrubbing algae off of glass. But snails are actually remarkably diverse. So like I was saying, with these snails, there are male and female snails. There are other snails that are hermaphrodites, so they're all the same. They've all got the same bits, and they'll stab each other with little harpoons to reproduce, which is strange. So like this, like garden snails will to make it so that they have it increases their reproductive success by just poking each other with these little harpoons. And another terrifyingly lively species of snail is the cone snail, which actually taught a class about it to some like a 1 hour long little class to like high school students in back when I was in undergrad. There's a species of snail that uses those radulas and covers them in a cocktail of protein derived poisons that can kill a person, and they can shoot little harpoons at fish and eat them. So there are snails out there that can eat fish, like whole, like a sardine sized.
How big
fish.
are those snails? Oh, okay. So it's not like,
or even like, I mean, not
salmon.
sardine, like a fish that's like 4 or 5 inches long. There's snails.
Still a fish.
There's those beautiful cone-shaped snails that you'll sometimes see, like in the tropics. Those cone snails are famous for their ability to hunt fish and be poisonous to humans. And those peptides are actually of a lot of interest for things like non opioid painkillers, and like kind of for their pharmaceutical interest, particularly because peptides and proteins and things are actually relatively well known how to make them in labs. So like that's kind of the part of the biotech industry that I've been involved in the most, is like figuring out how to make proteins. So it feels like a very doable thing to get some very interesting compounds, but we don't even understand how these snails necessarily, what all these parts of these snails do. Which is wild, because you think of a snail as just this little tiny thing that just, sits there and moves slowly and just like munches on a piece of lettuce or something. And they're actually very lively, interesting creatures with very diverse biology. And I think the one last thing that keeps coming up whenever I tell scientists that I have snails is, and Natalie, I don't mean to poke fun at you, but if you remember what you said when I said I had a bunch of snails, what was the problem that you thought I was going to have?
I think run out of space. That one? Or fight each other?
There was something.
What was it? I can't remember.
You asked where did all the shells come from.
Oh, yeah. And you know what's funny? I was going to ask that again because I forgot what your original answer was. So I did have that question pop up in my head. But they grow with them, right? The shells.
Yeah. So like snails are where shells come from, right? They'll grow shells. You have to make sure there's enough calcium in the water so that they can just grow a shell out of dissolved calcium.
You know what I think I was confusing them with hermit crabs, because don't they need shells? Joe, you have... Joe, I don't know if we've talked about this on this podcast. Joe has the oldest hermit crab of all time, so he'd know.
Yeah. This hermit crab's like... he's like a nuclear hermit crab. He's survived a lot. yeah, just a little side note before we get back to the actual stories here. This crab, I got a hermit crab as a Secret Santa gift back in high school in 2015. That crab was definitely lonely, so I went and got him a friend. And then the first crab died relatively shortly after, and so then I had this other crab who has been living with me since then. He is immortal, in my opinion, because in captivity, hermit crabs live an average of 2 years. In the wild, though, they can live up to 30, maybe even 40 years, depending. Yeah, I think it depends on the species and a few other things, but it depends on the source you're looking at. But like 30 years is like the like max that I've seen a lot. And so, yeah, who knows how long he'll be living. It could be when he goes, it may be like a death in the family. But I call him Sisyphus because he loves his hamster wheel, and he will go up run around on his little hamster wheel and go up to the top and then kind of like swing back down and keep going.
That's so
kind of like
cute.
It's actually, even though hermit crabs are kind of gross looking, like this is very adorable. And like like it's just really funny like how active he is. But
in his old age too.
Yeah, and I call him Sisyphus because there's the one of the Greek like legends is a guy named Sisyphus is sent to the underworld, and his punishment is that he has to push a boulder up a hill for eternity, and every time he gets to the top of the hill, the boulder falls back down, and he has to go back to the bottom of the hill and push it up again. And so that is my crab. And in this case, he's just going to the top of his wheel and back up again. But I actually haven't seen him in like 3 months because he's been hiding underground molting, which is something hermit crabs do. They shed their exoskeleton, they eat it, and then they grow a new one that is larger. They need to get rid of their exoskeleton so that they can grow, because their exoskeleton kind of like is hard. And so if you want to grow, you need to get rid of the hard shell on your outside. So yeah, but I haven't seen him in a while, partly because I think he cut off his own leg at one point.
Wait, what?
Yeah, it's oftentimes a sign of stress, but I think he injured himself climbing on the tank and just like dropped. Like he has a tendency to just climb on things and just drop himself from heights.
He's like the ultimate hermit crab death drop. Like,
snails will do this too.
He death drops so hard. Do they really?
Yeah, they'll climb the side of the tank and just let go and they'll like fall down.
Yeah,
but this in water though.
So
this is a land hermit crab you have, right?
Yeah, and I mean they do need water, salt water and fresh water. Story for another time. But I think in this case he may have fallen and injured himself, and he need to remove this damaged leg, and now he is probably growing a new one. So yeah, hermit crabs are wild. So yeah, like there's the coconut crab, which is the largest one. It's like, I don't know, like 2 feet wide. I might be slightly incorrect about that. But like they use actual coconuts as their shells, which is hilarious. Like wild. But yeah, so enough about hermit crabs. Sorry, back to
I got a question about hermit crabs now. I was gonna say like so 2 things. One is like I just want to comment that like the snails I have will live like 2 years, but I think they live longer in captivity than in the wild probably. But like, have you been taking notes on how you're taking care of this hermit crab? Like maybe everyone doing it in captivity is just doing it wrong, and you're doing it right. I mean that is.
Well,
I was going to say, that is not inconceivable. There's something about the way you're taking care of it that's different.
Well, maybe I literally just change his substrate every 6 months. I give him food, I give him water, fresh water and salt water, and literally just leave him alone, and that's it. Like, I think he's just like a nuclear hermit crab. That is that is my opinion.
He just got good.
He just got good. Unless nobody's continuously feeding or watering their hermit crabs, which is definitely possible. So,
I say because snails don't really need much; they'll eat the junk off of the tank. So they're very. Maybe people are just like, yeah, hermit crab. It's a invertebrate. It'll just eat stuff What if crab? Like maybe most people, the average is just like weighted by all the crabs, where people are just like, what do snails don't eat? I mean, it's allowed. Hermit crabs don't need to eat things. What's substrate? I'll just keep them in just a flat tank with nothing to dig into. Who knows?
I also imagine that a lot of hermit crab owners are like children who get them at like the county fair.
They are,
and then they forget about them a week later.
Yeah,
probably.
Joe, you should write a book.
You should write a book. My brother's got a fish from the county fair that has lived it's about the same age as your hermit crab. He was from the county, just the fair in the town that Joe and I grew up in, and my parents also had installed a reverse osmosis water filter at the same time. So I think like one thing that'll happen is tap water is really hazardous to animals living in it, because we treat tap water to keep stuff from growing in it. Like, because, you'd prefer to drink water that things aren't just rapidly growing in, and our bodies are more capable of filtering things out than something that's just literally living in it. We're just drinking water along with a bunch of other things, but that's what a fish breathes too. So it's definitely a potential factor there, but I don't know how that impacts hermit crabs.
They need well, you can't really just do tap water because the heavy metals actually damage their gills and make it hard for them to breathe.
And I bet a bunch of people just use tap water. That's the thing.
Some people do, I would imagine, but don't do that.
I guess a takeaway from this segment is if you have a animal that's not just like a cat or a dog or something, definitely look into whether or not tap water will kill it. That's not to say that tap water is dangerous, but tap water is for humans, right? It is meant to keep humans healthy, and our bodies are way different than that of a fish or a crab or I imagine lizards and spiders and snakes probably have their own special requirements.
Yeah.
Right. I think that's most of what I had to say about snails, but...
Well, I loved that. And Joe, I loved your little side note. Told you you'd have things, right? Joe's making a face at me right now. He's like, yeah, you're right, Natalie. I know. Okay, so I'm going to jump into my science story. So originally, I don't know if you can tell by my voice, but I've got the sniffles a little bit. It's allergy season. It was kicking up. And I was like, okay, I'm going to research my science story. It's going to be all about, I think it's like histamines, right? Isn't that what allergies are? Or don't they relate to allergies?
They're one of the chemical messengers that are involved in the allergic response.
Well, clearly I didn't look into those because I'm asking you what they are. And so over the weekend, I visited some family in Lancaster, Pennsylvania. I've got a cousin that lives out there. And my family is one of those families that's like super into hikes. Like we always do nature walks anytime we get together, and it's a big group of us. And so we were on this little nature walk, through this conservation center, and you could hear all like the birds. I'm a big birder too, just for background. Like I'm literally obsessed with birds. And we're in the woods, and all of a sudden you hear like a woodpecker, right? Like you've all heard like a woodpecker is such a distinct when it's drilling, right? You've definitely heard it. And it catches your attention because it's not like the typical bird call. And I was sitting there and I was like, how do woodpeckers not get concussions? Because how can they even just drill it? Like, what is the biomechanics behind that? Because my cousin, when we were visiting, had a concussion, and he was telling me all about that. And I'm like, oh my gosh. So concussions were just on my mind. So I was like, why don't I do some digging? And I did some research, and I'm going to tell you what I found. So woodpeckers use their drilling not just for finding food, but for nesting, for finding a mate, for establishing territory, and even communication. So they'll use pecking as a call. So it's like very instrumental to what they do. And a woodpecker's head strikes with at least 1,000 times the force of gravity. Yet the woodpecker experiences no harm. I was expecting jaw drops. I didn't see them on the Zoom, so I'm just going to keep going.
I'm struggling to process it.
I was just trying to do the math as to what that is in, what that is in, like, I don't know, some kind of units. I'm trying to think, like, what's...
It's a lot of units. I didn't do any math, but...
Is that the G-Force's experienced by the woodpecker's head?
Or
is that the...
Yeah.
Well, yeah?
The G-Force, it looks like it's, in my notes, it says 1000 G.
Oh, really?
Yeah.
Yikes. That'll end poorly for a human. I know that.
Exactly. Like a human would, like half of that, like a human would die. Like you can't, I know, like way more than half. I think
it's like 10 G's a human can withstand sustained or something like that. Maybe 20. There's like...
way less than half. And they can do this 20 times per second. Like they'll peck 20 times per second and have no impact. And honestly, I highly recommend, while I was doing my research, go and look at slow motion woodpeckers. It's so funny watching their head, like, because of course, like their head moves and you can see like the force like on it. It's honestly hilarious.
I think I need to look at this.
Yeah. If you're listening and you're not driving, or if you're at a computer, definitely look it up.
If you're driving and at a computer, I'm judging you right now.
You're breaking the law. Stop it. And for a while, scientists thought that it was just all shock absorption. Like, it was like, oh, they must just be able to, like, absorb the shock, like, in their skulls and in their beaks. Like, that's what it must be in order for them to be able to tolerate that. But a paper from last year found that this isn't the case, and shock absorption isn't needed to protect them from concussions. So, the paper found that because woodpeckers are smaller than humans, yes, they have a greater ability to withstand higher decelerations. So, a decrease in momentum in their brain size. So, because they're smaller, their brain size protects them from getting concussions. Relative to their size, in order to get a concussion or to have brain damage, they would need to hit the wood twice as fast. So they've really evolved to kind of have this perfect, execution of drilling that doesn't cause them any harm at all. And in fact, absorbing shocks would decrease the pecking performance. So you don't want so it disproves the original theory.
Huh.
And it's more than just their skulls. So that's not, or like their size, there's more to that, that protects them. There are a bunch of little, parts of their physiology that also assist with their pecking. So their beaks are chiseled so, you guys, I'm not a woodworker. I had to look up what a chisel is, but it's
really?
that flat, yes. That flat, and jump in if you have a better description, but it's not like stabbing something with a pen, like a pointed object, right? It's like flatter, and just look it up.
It's like
when
it's like a flathead screwdriver, but made for stabbing at things, as opposed to if you're trying to pry something open with a screwdriver. If you ever tried to do that and you've chipped it, well, you're in good company. I've got a few broken screwdrivers lying around. The chisel's, made to... It's like a big, thick, kind of somewhere between a crowbar and a screwdriver, I would say.
Thank you.
Yeah.
Very helpful. I would not have described it that way. So their beak is shaped that way, as opposed to other birds where their beak, like sparrows or something, where their beak is super pointed. And woodpeckers have the creepiest tongue you've ever seen in your life. Their tongue wraps around their entire skull. It is so long for one breed of woodpecker. I think, I didn't write this down in my notes, but there's one breed of...
I Googled it.
It's so bizarre, and I didn't even know that, that... It's very, very much like an anteater tongue. So right when they're drilling, it's really hard to get the insects that are, way in the tree, right? If they're hunting termites. So the tongue helps them to reach way into the tree, and the edge of their tongue has little spikes on it that their saliva is extra sticky, and it can grab the insects and just suck them back, just like an anteater. So when they're drilling, they're doing that as well. The tongue wrapping around their skull actually adds extra protection against the drilling. It helps soften the blow or decreases the blow to the head or something like that. It's really intense biomechanics around it. I'm not a biomechanic person, but if you want to have nightmares, look up a woodpecker tongue.
It's like it looks like it's like a harness, like running from their nose through their face back through the front of their face. So like it's like it wraps around the back of their head like some kind of weird like bungee cord. It's almost like how the straps in a Halloween mask go. I was like, I just looked at it. It's really weird.
Yeah, it's so weird. And I read about one species. I didn't put this in my notes, but I think its tongue is like 3 times the length of its body. Like, they're insane. Like, they're so long. And each woodpecker breed has different tongue specialties. Like the northern flicker, their tongue is way flatter, and I think that helps them kind of get into crevices more. Ornithologists are listening to this and they're like, this girl's butchering this story.
Yeah, I looked I think it might be 1/3 the size of their body, but
okay, there's a 3 in there somewhere. I didn't put it in my notes, but don't quote me on that.
But woodpeckers can be pretty big, so that's still a really long tongue.
Yeah. And so you might be thinking, like, why? Like, why did they evolve like this? What's the point? And so some theories suggest food scarcity. So millions of years ago, there's a lot of competition for food, for nesting, all that kind of stuff. So woodpeckers slowly started, they didn't evolve to what they are today overnight, but their ancestors started pecking at trees to get that untapped insect food source under the bark of the trees. And then they, the drilling just advanced, and this food source was inaccessible to other birds. And so millions of years later, we have the modern woodpecker. And as time went on, they got more and more specialized. So the International Ornithological Committee now recognizes 239 species of woodpecker.
Wow.
Mm-hmm. I butchered some of that, but I found that very interesting.
Oh yeah. Right. No, this is wild.
Yeah, you're looking at 2 now, Joe?
Yeah, I don't understand how the woodpecker tongue actually like extends.
It literally goes out and then it comes back from the head. Like,
that's wild.
It's so wild. Yeah, I looked up a demonstration of it, or like an image.
It's like the tongue starts and ends in the place you expect the tongue to end up, but just like going through Boston, you can start on one end of trying to get like in one part of the city and trying to get to another place very close, and you happen to go around the entire friggin' city to get there. It's like that, but with a tongue. Like, where it's just like
from Boston,
it goes from the nose to the mouth by way of the back of the head.
How long is, like, what does a human tongue look like? I'm gonna look that up.
It's
because, like, how far back do ours go?
Joe, would you know?
I mean, our tongue kind of goes down into our throat a little bit. It kind of like basically ends right at the little full, like the epiglottis, the little thing that like covers your like your trachea, your air hole. That goes to your lungs when you swallow. Interestingly, there's some taste receptors on your epiglottis itself. Yeah, it goes down into our throat instead of up and wrapping around our brains, which major distinction. Yeah.
So our tongues end about where you expect them to end. It's the nice little slide in your mouth. It goes down to exactly where you'd expect the tongue to end up, which is the part of your body that decides. The epiglottis, is that the part that decides whether or not it's air or not air?
Wait, can
there's a thing that's like normally if you're just breathing, it's like the path is open to your lungs, and then there's like a little thing like it comes down, so you don't end up with green bean casserole in your lungs.
In theory, at least. Yeah. Yes.
Okay.
Yeah. The epiglottis, the little air hole flap, very important. You want that to work.
One would assume. I like to breathe when I want to breathe and eat when I want to eat, not the other way around.
Yeah. It's hard to breathe while you're swallowing. So, Yeah, just make sure you try not to do those two things at the same time.
Now I'm gonna.
No, Natalie.
Please don't joke.
Alive. Yeah, I guess I can share my little story. This one is a bit different. It's not really sciencey per se, but it has to do with the soft side of science, like soft skills, networking, really bringing up the next generation. And I think it's like this side of science is the side that is not really talked about nearly as much as it should be. And it's equally, if not more so important than the actual like scientific method. Like really, like in my personal opinion, like science is a way of understanding and interpreting the world. And certainly like any other way of understanding and interpreting the world beyond like explicit like sensory information, in my personal opinion, it needs to be taught. And so it certainly there are many other ways to make sense of the world, and science is just one of them. But like it's really, really important that if you're in the sciences, you have good mentors who can teach you how to be a scientist and how to think scientifically, and also just help you get to where you want to go. And so I think maybe we should actually at some point like have an episode focused on mentoring and mentorships and things like that. But for now, I'll just kind of share like there was a time where I wanted to learn about like what it was like to shadow a doctor and what it was like to do work in like a biomedical research lab and things like that. And I was really struggling to find opportunities. I went to this is really funny. I went to a insurance company in town that worked with some doctors, and I was like, "Hey, please connect me. I want to shadow someone." Like I was that desperate.
Pulling out all the stops, honestly, like that kind of grit is impressive, though.
Yeah, there was like it was very challenging to like. I really didn't know anyone who was like an actual doctor in my in my own life, beyond the doctors that I actually like met in the clinic. Like I didn't know anyone like in my social network who did anything medicine related besides a cousin who I hadn't seen that much at the time. And I really honestly didn't even know that she was a doctor at this point in my career, I guess. Not that my career has really taken off too much yet, but I ended up connecting with someone who worked in like at a medical / research institute through my old Boy Scout troop. And this guy was kind enough after multiple like relatively intense interviews and conversations to take me on a tour of this research institute that he worked at. And where he was going to try and connect me with a doctor to shadow. And while we were there, we were walking around the floor and he was showing me a bunch of the research labs. And this was like my first time that I'd been in like a big like biomedical research institute. This was actually, this was sophomore year of college.
Oh.
So yeah, I'd been in like industry stuff before, but like I knew that I wanted to do like biomedicine, like academic, like biomedical research. And this was my first time being in a place where I could do that.
Could you define biomedicine? So I think I'm wondering, because I know you had done work in a laboratory setting prior to this.
Yeah. So I had done work in like standard, like academic labs, like just biology labs that did biology stuff like for the sake of doing like understanding biology, which certainly these kinds of labs also do, but there's more, it's the end goal I think is a little different. And so like in previous labs it was either to understand like for example like how does this specific protein work, and that was the end goal, or like how can we turn this, like, for example, when I was working over at New England Biolabs, how can we take this understanding that we have of biology and turn it into a product or a tool that can be used to probe biology? But in this context, I want to work in a lab where they're like, we're going to understand biology and we're going to try and use it to find a way to help patients. And to me, was like something very different than certainly like if you just look at biology in general, like obviously all of that fits underneath and different people have different opinions about how different those things are. But for me, like this was my first opportunity to be in a lab where the end goal was that. What's up?
I was
Sam,
just curious because like I should clarify, like when I said like at the beginning I was like I arguably a researcher. I've moved to like development, which is a whole nother category of thing. But like but like I still think like what I do is supposed to help patients, and what I've done in pharmaceutical companies in the past when I was interning places, I was doing stuff that's supposed to help patients. So I guess what I'm thinking about is like when I was in a laboratory that was trying to develop therapeutics, is that what you're thinking of as biomedicine? Is that like
anything with some kind of clinical connotation or clinical end goal? That's kind of how I am defining it right now. But the really thinking about, and I obviously like other people have slightly different definitions, but when I think of biomedicine, I really think of the medicine part of it. And that's probably my own bias. So I would classify what you do as biomedicine as well. Or in doing biomedical research. But in like, I really like, at previous labs, I was lucky enough to have mentors who taught me, but they also explicitly said, hey, if you're interested in doing a MD PhD program, you really need to do like biomedical research and see what that's actually like.
So what's the difference?
The end goal of the work. Like, so explicitly, like what kinds of research questions are we asking?
Okay.
Like, certainly, like, can we turn this into a therapy for patients? And like is different from, can we turn this into a product to sell?
Okay. I'm getting confused because it's the bio and then the M, and I'm getting mixed up.
So I'm still, okay. Now I'm confused again because like,
go ahead.
And this depends on a company's philosophy, for example, but like, corporate pharmaceutical stuff is biomedicine, but it's also product focused, right? Like
it's both, but I had
things, so
I had not had an experience in like pharmaceuticals at all, nor just pure like we're understanding this for a therapy.
Okay, so like the distinctions between all of that stuff and the stuff I was doing in grad school, where I was like, I'm characterizing a protein for the purpose of characterizing a protein. That's the distinction you're making. I'm sorry for being very confused about this.
Oh no, it's Don't apologize. I think it's an idea that I had not really explicitly defined for myself prior to this. So, and I think it's still vague and hard to define for people, even in whatever we call biomedicine. But basically, I wanted to do research that was going to directly help patients, whether it was going to be eventually also profitable or not. And so this was my first potential opportunity to even like step foot into a lab that really was doing that, like physically connected to a hospital, people who were going to like doing research in these labs were explicitly like going and also working in the clinic and things like that. And that was super cool. And so when this guy and I were walking around the labs and he was showing me, it turned out that he was running late for a meeting. And I was like, hey, you should just like go to your meeting. Like, thanks so much for showing me around. I'll just head out. And he said, no, this is the most important part of my day.
That is so cute.
Oh my gosh.
And it was really like this big like science and medicine guy, like to me like a giant in the field, like it was very clear, like in that moment the most important thing was kind of helping the next generation get their foot in the door. And I think that to me, like, is something that's incredibly important. And that was just like now when I have, like, I'm mentoring a few students, and they like, I'm helping them find jobs after college, like short term, like 2 to 3 year research jobs before they go on to a like another like degree, like an MD or PhD, or if they choose to stay in that kind of research position. And sometimes they're like, Joe, I'm so sorry for taking up so much time. And I'm like, don't worry. This is the most important part of my day.
You're paving the
And
way.
so,
You're like passing the torch.
Yeah, and that's explicitly what a lot of science is, or what a lot of what it should be in some contexts. And like, so that mentoring aspect is a mindset that I think is really important for scientists to have, because you can't solve all the problems on your own, nor can you understand everything on your own, and it's going to take hundreds of thousands of years maybe to even understand like a small portion of like everything that exists in the world. And so we need more people to do that. And yeah, I don't know where I was going with that, but I think it's just a really powerful short little anecdote.
Yeah, it's a powerful message.
Yeah, and really, like, that moment was kind of like, I see it as a significant inflection point in my development as a physician scientist, and if I truly choose to do that, but like at least getting to an MD PhD program, and like there were people who are willing to help me along the way, and like I'm gonna try and do the same for other people, and hopefully those people will do the same for the next people, and that's how it's supposed to be. And certainly we should try and ensure that that kind of assistance and mentorship is distributed fairly for everyone. Like it can't always just be like, oh, I have this connection to this person.
Right.
Like we got to reach out to people who need that mentorship or who want it, who don't necessarily have it otherwise. But it's critical. So yeah, I don't know where I was going with that.
But you don't even like,
really
you're saying you don't know where you were going, but like there's a story there. Like you literally told the whole story. You went there. You went there, girl. Don't even worry about it.
I guess we did.
Yeah. Yeah. I mean, I think that's so important. Like, I've had kind of a circuitous path lately through kind of the biosciences space, but I think early on, I think like you talked about mentorship, I was lucky enough to have a internship at Harvard. There was a professor there who was like doing like these like summer to take on interns over the summer, like from like a bunch of schools around the area. And I think this was actually after that he had a few of us, like a few other interns, and I came back for this, like help him prep stuff for classes. And he's like very into outreach. I'll mention his name. His name's I think it's like Dr. I think Alain Viel is how you pronounce his name. We could never quite nail the pronunciation, but he at one point we were like helping him, I think, like prepare kimchi, so like the fermented Korean cabbage dish. Like we were taking like commercially available kimchi and sequencing what species were present in it. And at one point he gets the data back and he's looking at it, like we're looking at the next week, and he's like, you know, that there's this species in, you know, the cabbage kimchi, and there's like, I think there was like carrot or something, and it was like, and it's not in this one. He's like, yeah, that kind of makes sense. And we're like, it does? He goes, actually, no, I have no idea what I'm talking about. Like, and like, he's a very, very smart person, and he's advised on a lot of projects that probably, honestly, at this point, you know, a lot of people have probably seen, but he's not an expert on kimchi, and it was really funny to see this guy who I really respect kind of be like, yeah, I actually don't know everything I'm talking about. I'm kind of figuring stuff out too. And, you know, sometimes I'll be at work and I'll be like looking at the thing. I'm like, I have no idea what's going on here. Or like, you know, in any lab, it's like, okay, but that's normal. That's the scientific process. Not knowing is really important. And it was just like this very one-off moment. He probably wouldn't even remember it. And I'm sitting here like, that to me is one of the most important things, is to see people who you really respect in science, who are really capable of being like, yeah, I don't know everything. Like, why should I know about cabbage? You know, like, it's like, there's someone else that's their area of expertise. And to really, you know, I think that, like, hear that from someone at those highest levels, it has always taught me that that's like what good scientific mentorship looks like and what good science looks like. So it's the same idea, saying like, yeah, mentorship's really important. And obviously, you know, the professor was talking about, he was doing mentoring, he understood the importance of mentorship. But like, I've always thought going forward, like if I talk to a scientist, and sometimes I'll ask some question that pops in my head, and the best scientists I've been kind of always willing to say that they don't know, or, you know, try to work through the problem, which is just so underappreciated. So I was thinking about that as you were telling your story, Joe. I was like, this is a great story, because at the end of the day, the most important part of science is, you know, how we interact with each other and how we teach each other how to do it. And, you know, I think some people are better than others, and it's really, really important to know that, like, you're not going to know everything, and you should focus on mentoring people and working through stuff. And yeah, I just thought your story is super great. It made me think of one of my own. So
yeah. And I think the other thing is that, like, for those of you listening, like, in my personal opinion, like, this kind of thing, like just how important good mentors are, is true regardless of what field you're in, regardless of where you are, whether you're a construction worker, or in business or policy, or whether you are like, I don't know, mining, like literally anything. Like, you need people who can teach you and who can guide you, and keeping an eye out for the good ones is really important. And like, they won't always necessarily tell you exactly what you want to hear, but they're really going to tell you what you need to hear in a kind and constructive way, in theory. So yeah, I don't know where I was going with that one, but I think maybe we got there too.
That seems to be the theme of your night, Joe.
I'm just one big tangent today, but that's okay.
Well, thanks everyone for tuning in to listen to our science stories. You can find us on Twitter at the Interactome, on Instagram at interactome_media, and in our Twitter you can also get our link tree, which sends you to our website, our Spotify, everywhere you can get your podcasts, all that kind of jazz. Let us know what you thought of this episode. Feel free to reach out. And if you have like other science stories or ideas that you kind of want to share, you should. And you should just reach out to us, and we can all be besties. So
I know this science story came, I think, pretty quick on the heels of the other one. We have a lot of like guests and things lined up, but you know, this is kind of the way things have worked out with the schedule right now. And you know, let us know too if you happen to know anyone who'd be a cool guest, or like we've definitely had certainly friends be like, I need to be on the podcast, and it happens eventually. But you know, it's well, we're not going to necessarily give you the essential opportunity for mentorship. You know, it's I think the whole point of this is sharing those stories with the world too, just like, you know, those mentors and everything else. And hopefully someday we can be half as good as those people are, and half as good as Joe is to his mentees, right?
All right, folks. Well, we'll catch you next time.
Thanks for listening.